Hi everyone, welcome to Focal Point, and we are going to see some more examples which is related with the concept of static scoping. So let's see what we have taken in here. So let's see the program. So as usual, we have included our standard input output header file, and we are using two functions, and we have taken the main function in here, and we have initialized and defined and initialized our two variables x and y. Now we have included our for loop in here, which will be running for 2 times because I is starting from 1 to 2, so this will be executed 2 times. We have included our two functions in here, f and g, and we have called. These are the definitions of a function f and g, in which we are taking integer x with the call by value. So let's see what will be the output of it. So these are the simple variables that we have taken. So these are the local variables. So now what we have to do, we just have to take a stack where these all value will be stored. So this is the main function, and in which our integer x and y are defined and initialized with 10. Okay, this is initialized with the 10 and y is initialized with 5. Okay, so now our for loop is going on. So loop will be for 2 times. So in first time, what will be the value? So our y is equals to 5, so this is y is equals to y plus fx plus jx. So first of all, if we read from left to right, then y is equals to y plus 5, that means y is equals to 5 plus the return value from fx and return value from gx. So let's call the fx. Okay, so we have called f, and what is the value of x? That is 10. Okay, so f10 we are calling in here. So what is the definition of x? Here integer x is taken from the call by value, so x will be 10 in here because that is the value of that we have passed. So we have passed 10, so it will be integer x and a value of x will be 10, and we have defined the y, but we have not initialized with any number, and that's why the default value will be a garbage value. We have now incremented our 10, so then it will be 11 in here. Okay, and now we have changed the value of y by calling gx. So we have to call the gx from here, and what is the value of x? That is 11, so g11 will be called in here. So what is the definition of this g? X value will be taken with the call by value, that is 11, and a static, this is really very important, this is the local variable but a static local variable. So we have taken the static variable, so static memory. So as we have mentioned, this is a static, so its value, its memory will not be allocated in this area, but it will be allocated in static area. Okay, so let's assume this is a static area. So inside this there will be memory allocated for our function g. So this is really very important because this is the static memory, but for the g this memory is allocated. Okay, for this g this memory is allocated. So let's write this g outside of this box. So this is our g area. Okay, this is our g area. So we have defined the integer y and initialized with 7. So this space will be used by g function. Whenever g function is called, this space is used. Okay, and now we are going to change our value. Y is equal to y plus 3. So y is not defined here, so it will be searched in the static area. So y is found, and y will be changed to 10 because we are adding a value in here. So just change this value to 10. So this will be changed to 10. And now what we are going to do, we are just returning x plus y. So what will be returned? X plus y will be returned. What is x? X is 11 and y is 10. So what will be the return value? Return will be 11 plus 10, that will be 21 will be returned. So this will be vanished, and this value will be taken by the function f, and this value of y, because this return value will be go inside the y, so this value will be returned to y, and x plus y will be returned. So what is the x and y? X and y, will make sure that this memory will not be vanished, because this is the static memory. This is popped out. Okay, so we can remove this area, but we cannot remove this area because this is defined as a static, and this is allocated for g function. Whenever the g function is called, that memory for the y will be used. So we are working on f10, and we have to return a value. What it will be returned? Return value will be this and this. So 2 and 3, 32 will be returned. Okay, so here we are returning 32 to which? To main. So where this value will be gone? This will be gone to this f. So we have to add this 5 plus 32. So 32 will be added in here, and plus we have to call now gx. Okay, so as this will be popped out from here, because that was the last line. You can see this was the last line where we have returned. So this memory of this stack will be popped out from here. So then let's just clear this from here. Okay, and now what we'll be doing, we will take one more stack, and our gx will be called, because our next requirement is gx. Okay, so now gx is called. What is the value of x? That is 10. So g10 will be called in here. And now whatever the definition of g, the definition of g says that we have, but this is, I have told you that for the static variables, so memory is allocated only once, and as we have called g function earlier, so memory is already allocated for this integer, so this line will not be executed again we have to execute only this line. So what will be the alteration here? We have to just increase this value with 3, so y value will be 13, and we have to first of all we need to take that x will be 10 and y will be 13, and now we have to return a value. What will be returned? 13 plus 10. 13 plus 10 is 3, and 23 will be returned. 23 will be returned to where? 23 will be returned to here, gx. So our 23 will be returned to here, and now this will be vanished. So let's clear this from here, because this is just vanished from the memory, and this is the output. So what is the output if you just add it? So what will be printed in here? The printed value will be 3 2 5 and 5 5 10 and 1 6 to 60 will be printed. So first output is 60. Okay, first output is 60. So let's write that out in here. First output is 60. Okay, so the new value of y is, we have added this, new value of y is 60. Okay, so just remove that out. Okay, so this is our main, and first value of y 60, and our variable y in here is 30, and this is allocated for g function. Okay, so these are the new updated values, and this is the main. So for the next iteration the same thing will be done. So let's see what will be the new printed value. So this is something that will be done again. So next value that is required is fx. Okay, so x value is same, of course, x is same 10 and y is updated by 16. So now what we have to do, we have to call a function f10 again. The same thing will be done again. So what will be done now? X is equals to 10 because this is the call by value. Y is not initialized, so it will be garbage value. We have incremented x by 1 and we have called gx. So let's call g11 again. So what will be the output from here? We have already taken this static, we have already defined that earlier, so this line will not be executed, and we need to increment our variable in the static space, so it will be 16, and now we have to return our x and y. So what is the value of x? X is 11 in here and y is 16 in here. So what will be the return value? Return will be 7 and 2, 27 will be returned from here to here. Okay, so this memory is vanished because this will be popped out, so just remove this, and we have got 27 in here. So we have just came back to the f10. So we are in here, and now we have to return a value. What will be returned? Return value will be this plus this, x plus y will be returned. So 8 and 30, so 38 will be returned from here. So after returning, this will be vanished, and we will get value from in here. This is the value of fx. So 60 plus 38, and now what is the requirement? Requirement is fgx, sorry. So this is popped out from the memory, and let's update our value in here as well. So our new value is 16. So just write that in here, choose the different color. Okay, so 16 is our new value inside the static area. Now again, what is the requirement? That is gx. Let's see, y is equal to fx and gx. So gx will be called in here, and x value is 10 again. So g10 will be called. Okay, x value will be 10 and y value will be 16. So return value will be what? 6 and 26. So plus 26 will be coming from here. So what will be the final output of it? So just add it. This is 14, so 4. I think I've done some mistake in here. So what will be the return value? We need to change this value to 19 because 3 will be added. Now x plus y will be returned, that will be 29. Okay, so 29 will be returned from here. So after adding this, what will be the output? Output will be 7, 2 and 1. So 127 will be the output. That means 127 will be printed in here. Second time 127 will be printed. Second time 127 will be printed. So our output should be 60, and as this is after that the condition will be false and it will be come out of the loop, and after that our program will be finished because our main function will also be deleted, and after that our static area is also deleted. So what should be the output of it? The output of the it should be printing 16 127. So let run this program. First of all, save this. After that, just run this. That is gone. Yes, run this. Code.c. yeah, look, this is the output of it. 16.27. Okay, 16.27 is the output that we have derived as well. So this is the concept of our static scoping, where we have used different local variables, the static local variables. You can also try this code, just copy it and try by your own. Just opening the code once again. If you want, just copy it and try from your side and confirm that everything is fine or not. Thank you so much.